Good evening, everyone, and thank you for coming to tonight's Tech Talk. We're joined here today with JD Armada, who will be talking to us about CI/CD. My name is Grant, and I will be moderating our talk this evening. If you have a question for our speaker, please send me a direct message, and I will present those at the end. And we will answer as many questions as time allows. So before we get started, let's unmute ourselves and give our speaker a round of applause.
Let's go, JD.
Let's go, JD. You got this, bro.
Yeah. Woo.
All right, JD, take it away.
Awesome. Thank you so much, everybody. Thank you, Grant. Hello, everyone. Thank you so much for coming to my Tech Talk. My name is JD Armada, and tonight I'll be talking to you folks about continuous integration and continuous delivery / deployment, or CI/CD. Now, before I get started, I would love to take a moment to thank Bracklet for sponsoring this Tech Talk. All right, so let's dive into it. First off, here's a little bit of an agenda of what we'll be discussing today. We're going to go over some traditional methodologies on project management and where CI/CD falls into, the problems with those traditional methods and how CI/CD addresses them. And we'll look at each step of CI/CD in depth and some optimization and best practices. So let's dive in. So a quick summary on CI/CD and why it's important. So continuous integration and continuous delivery is a software practice that looks to improve the speed, efficiency, and reliability of delivering software. In short, CI/CD will provide your team of developers with a bunch of tools to automate the process of integrating, testing, and deploying code to production. Now, you're probably asking, why should you care? So there's a ton of benefits I'll go over shortly, but the most important reason is that you'll get your code, application, feature, whatever you're building to the market faster. Simply, code that's in production is making money, while code that's sitting in a hard drive somewhere is not. Now, to give y'all some context on CI/CD, I first want to discuss the two approaches to project management and where CI/CD falls into. So the first one is the traditional method. It's called the waterfall method. It's basically one big development cycle that flows into the next in isolated phases. Then in the future, we have the agile method, which came afterwards, and it breaks down project management into iterative development cycles that can run in parallel. And CI/CD falls into this agile buckets, and it's actually the most common agile practice. So let's dive a little deeper into the waterfall method and see why so many teams today have made the switch into agile. So this approach is very linear and sequential, meaning that one step cannot begin without completing the previous step, kind of like a waterfall. That means you can't skip any steps, but let's go through each step in depth. First up is the requirements. So this step is where you gather input from your customers based on what their needs are, pain points, usually placed in some sort of formal document. Next up is analysis. This is where you would analyze whether you can actually implement your new software, whether it would fit your system specs, as well as analyze whether you actually have the necessary resources to do so. Next up is design. So this is where you would outline your technical requirements, set up your wireframes, etc. Basically where you would outline the technical design on a high level. Next, we have coding and implementation. This is where the real work begins, where your engineers get to write code and develop their source codes using the design logic of the previous steps. So you can kind of see why you won't be able to skip any steps because one depends on the other. Finally, of course, we have testing. This is where you set up your test, debug, whether that's using unit test, integration test, end-to-end testing, etc. Once those tests pass, we move on to operation deployment. You can deploy your product to the customer, where then you can maintain and provide support in the form of patches and updates. Now, this model is great for a lot of reasons. Some of the benefits of using the waterfall model is that it enables large teams to move through these steps together and enables them to work on a common goal. It provides an easy to follow framework for structure and discipline. It's also easier for team members to understand which tasks they're responsible for without having to worry about the previous steps or what's coming up next. It provides a nice visual for your team on specific milestones and deadlines. Basically, it's great for projects that need specific documentation and that has to work on the first try. But there's a reason why there was a need for agile methods such as CI/CD, as the waterfall method also had a lot of drawbacks. First and foremost, the release cycles were really slow. Again, each step is sequential, meaning that you can't skip any steps. And even worse, if you find a flaw in the middle, you're going to have to start the whole process over, which leads into the next drawback, which is that it's very inflexible and the design isn't adaptive. Again, the sequential nature makes it impossible to make quick changes to the software or respond to customer feedback in real time. It also makes it a lot harder for teams to collaborate with each other, as developers worked in silos independently, which makes it a lot more difficult to find issues and fix them. You also can't overlap any work and work simultaneously, both of which can reduce your overall efficiency. Next, we also have high failure rates. Now, with this model, again, if you remember, testing is not done until the later stages, and that can cause a lot of problems. And without automated testing, your developers have to rely on manual testing, which brings on a lot of human error and bugs. And with that, we also have high costs. Since a lot of the processes are done manually, you have a lot more costs associated with testing, debugging, and fixing issues. Your developers have to spend more time, which takes them away from the ability to develop new products. Basically, if you have a project that's complex in nature and you need it to be able to respond quickly and efficiently to customers, the waterfall model is just not going to cut it. So, how does Agile and specifically CI/CD address these problems? So here's a little model for the CI/CD workflow, which again is the most common Agile practice. In this workflow, the steps are written out in an infinity loop because it's a cycle that repeats forever. We'll start up on the top left with the code. This is where your developers will write out the code. Next up, the code is built or compiled. Then it's tested for bugs. And finally, it's deployed into production where the customer will finally get to use the product. We'll then monitor their feedback and use that feedback to plan improvements and changes. After that, we repeat the whole cycle all over again. So how does CI/CD specifically address the problems with the waterfall method? First, CI/CD offers much faster release cycles because it focuses on a lot of automation. So teams can release software a lot more frequently without having to wait for that long sequential process. This allows developers to respond quickly to customer needs. Next, the rigid structure of the waterfall method makes it quite inflexible, while agile workflows are the opposite. Instead of delivering software in one big launch, an agile team delivers small but consumable increments that allows teams to be able to adapt to changing needs, requirements, and changing technologies. Then the continuous integration part of CI/CD means that developers are constantly integrating and testing their code, which not only encourages, but almost requires developers to collaborate closely. Finally, in contrast to the high cost of the waterfall method, CI/CD focuses on automating, which reduces the work that each developer has to do, freeing them up to do what they do best, which is to build new products. So let's talk about each step in CI/CD. So CI, continuous integration. In continuous integration, we want to think build and test. In this workflow, developers use a shared repository and commit changes usually multiple times a day. Then each commit is analyzed and verified by an automated build, which includes testing to find any integration errors. These tests include unit, validation, and format testing. Some common tech used in continuous integration for the build phase is Maven, NPM Gradle. For test phase, it's Selenium and JUnit. For the scan phase, it's Black Duck and SonarQube. And for the upload phase, it's JFrog and Nexus Pro. So let's move on to continuous delivery and deployment. If CI is the build and test phase, continuous delivery is the package and deploy phase. So this will represent our pipeline to production ready code. After the upload step, it's deployed into the dev server, then into the UAT server, and finally, if it passes all the tests, it's deployed onto a production server. Just like continuous integration, this pipeline, it relies heavily on a lot of automated tasks and automated testing. Some tools, common tools used with continuous deployment is Ansible and Helm. Now, to put it all together, here's a little visual on both the steps put together. Now, if you are implementing this workflow into your dev team, here's how to optimize this pipeline and the best practices. First of all, you want to keep all your code, config files, and documentation in a single centralized version-controlled repo. Next up, you want to automate as much as you can in order to save time and reduce the likelihood for human error. Next, you want to use a consistent build process. You want to make sure this build process is identical throughout your dev team so you can minimize the chances for any merge problems. I know from personal history, merge problems, I hate it. And next up, you want to make sure your team is enabled to work in parallel, that they can work simultaneously. So you have to structure your tasks and tests to run in parallel, which can speed up the whole process. Then you want to implement as much comprehensive testing as you can, such as unit tests, integration, end-to-end testing to ensure that everything is A-OK at every step. After that, after building this pipeline, you want to continuously monitor the performance and use feedback such as metrics in order to identify any bottlenecks and to see if there's any other opportunities to further optimize this pipeline. And within your dev team, you want to foster a culture of collaboration. You want to make sure that every team is on the same page and working towards a shared goal. Finally, make sure to keep security in mind. Integrate some security checks such as static code analysis, security breach tests, and dependency checks. So here's some challenges with CI/CD. There's obviously a learning curve. It takes a lot of time to be able to learn how to use all these tools required for a CI/CD pipeline. It can be difficult to embed CI/CD into existing projects, especially for large-scale legacy applications. There could be some problems with version control. If you can imagine, you have devs all over the world. With them committing and integrating multiple times a day, it can be difficult to establish a comprehensive version control system. And another challenge is that for a lot of dev teams, multiple code integrations is going to signal a big cultural shift within that dev team. So you have to make sure that your dev team has a cultural buy-in for using CI/CD to make sure that the shift will go smoothly. Here's some key takeaways. We learned about the waterfall method versus the agile and why the need for CI/CD came up. CI/CD focuses on automation to save time and money and get your software out to production the fastest. Implementing CI/CD will change the culture of your dev teams, and we learned about some best practices for the CI/CD pipelines. That'll be the end of my tech talk. Here's my resource page. And if you would like to keep discussing CI/CD or any ideas you have, please reach out and let's chat.
All right, everyone. So let's unmute to give another round of applause for JD.
Let's go, JD.
There we go.
Let's
go,
JD.
Killed it. Awesome.
Now let's address some questions from our audience. And our first question is from Simon, and they ask, what do you mean by incurring technical debt when talking about continuous integration?
Great question. Thank you, Simon. What I meant about that is that let's go back to the waterfall method. Like I said, the testing phase is not until the very end of the cycle. So imagine if you integrate some code with some errors. You know, it's working, but it's got some errors. By the time you get to the testing phase, those errors are going to be so deep into your code base that it's going to take so much resources to be able to identify and fix them. And that's what I mean by incurring technical debt. And how continuous integration fixes that is that every step, every time you integrate or commit something, every step is tested, it's verified to make sure that there's no errors. Thank you, Simon.
Okay, so that seems to be all the time we have. So we will conclude our talk here. So thank you all so much for joining us and have a great night.